Hello, everyone. Now, we are required to draw a simulated circuit diagram on the exhaust fan simulation module using the simulation software Multisim based on the circuit knowledge and principles we have learned before. If specific components are not available in the component library, use components with similar parameters as substitutes. Additionally, measure the circuit's operating parameters to verify whether its load regulation meets the requirements. The learning objective of this lesson is to learn how to use simulation to verify the function of a designed circuit. This simulation experiment is to design the exhaust fan simulation module based on the schematic diagram. When a high-level input is applied, the transistor is in cutoff mode, the relay does not engage, and the output voltage is 0 volt with an output current of 0 ampere. When a low-level input is applied, the transistor is in saturation mode, the relay engages, and the output voltage is 5 volts with an output current of approximately 333 milliamperes. Therefore, the circuit's load regulation is sufficient for the small exhaust fan and the exhausting indicator light. Now let's learn how to draw a simulated circuit. Step 1. Create a new simulation file and save it. Left-click on File in the common menu bar, select Design, and then click on New File to create a blank design. To better save the related operation data of the design, we should first create a folder and name it appropriately, and then name the design file Simulation Experiment on the exhaust fan simulation module and save it in the folder. Step 2. Design the circuit in the design file. The first process is to find the corresponding simulation components based on the schematic diagram of the circuit. First, set the width and height of the workspace to 50 and 35. Place a switch S1, resistors R1, R2, and R3 with resistance values of 4.7 kiloohms, 15 ohms and 1 kiloohm. And a diode D1. Second, place a PNP transistor Q1 and flip it vertically, and a relay K1. Then, add multimeters XMM1 and XMM2, with XMM1 measuring DC current and XMM2 measuring DC voltage. Add 3 VCCs and 3 GNDs. VCC1 is 4.5 volts and the other ones are 5 volts. Add 2 capacitors, with a capacitance of 0.1 microfarad for C1 and 10 microfarads for C2. The second process is to connect the corresponding simulation components according to the schematic diagram of the circuit. Arrange the orientation of each component. Then, connect VCC1, GND, and R3 to S1 respectively as shown in the video. Connect one end of R1 between S1 and R3, and the other end to VCC2. As shown in the video, after connecting D1 and one end of K1 to VCC2, connect the other end of K1 and D1 to the emitting electrode of transistor Q1. Connect the base of transistor Q1 to R3 and the collector electrode to GND. Connect one end of K1 to VCC2, and the other end to R2, which is connected to the positive electrode of XMM1, and connect the negative electrode of XMM1 to GND. Connect XMM2 to R2 and ground. The connection of the capacitor is shown in the video. Now we have finished the process of connecting the corresponding simulation components according to the schematic diagram of the circuit. Next, we will proceed with the simulation test. Click on the simulation button using the mouse to start the simulation. As shown in the video, when a high-level input is applied, the transistor is in cutoff mode, the relay does not engage, and the output voltage is 0 volt with an output current of 0 ampere. When a low-level input is applied, the transistor is in saturation mode, the relay engages, and the output voltage is 5 volts with the output current of approximately 333 milliamperes. Therefore, the circuit's load regulation is sufficient for the small exhaust fan and the exhausting indicator light. The simulation achieves the expected results and is successful. Through this lesson, we have preliminarily learned to use simulation to verify the function of the exhaust fan simulation module. Please review and consolidate what you have learned after class. That's the end of this lesson. Thank you for watching.